Hello. AgEASY works with agricultural customers to help you save energy. The program, offered through the Public Purpose Program charge on your utility bills, provides your business with energy audits, technical assistance, web-based energy monitoring, and more. Contact our team today to learn out how to take advantage of these benefits. In this video, you'll learn about the typical equipment in indoor agricultural facilities and how to identify energy-saving opportunities to lower your monthly energy bills. As I'm sure you're aware, your energy bill accounts for a significant portion of your operating expenses, typically ranging between 50% and 75% of your total production cost. The good news is that there are ways to not only reduce that cost, but you can also earn incentives from your local utility to help your facility become more energy efficient. An indoor cultivation facility uses a significant amount of energy compared to other types of facilities. As an example, according to New Frontier data, the lighting demand of an indoor cannabis cultivation facility is 70 times more intensive than that of a standard commercial office building. And that is just one of several energy-consuming systems put to continuous use in indoor ag facilities. Of those systems, the greatest opportunity to save energy starts with the most energy-intensive systems, which are horticultural light, heating, cooling, and air conditioning or HVAC, and dehumidification. These three systems make up about 90% of your entire energy use. Let's begin with horticultural lighting. With the advancements in horticultural lighting over the last 5 years, there are now viable options outside of the traditional lighting technologies like high-pressure sodium, ceramic metal halide, and fluorescent T5s. These traditional technologies use a significant amount of energy to run and add a tremendous amount of heat into the cultivation. Breakthroughs with LEDs and their light spectrum, ability, and intensity have allowed cultivators to reduce their energy usage while allowing for more controllability in their facilities without sacrificing yield, quantity, or quality. LEDs have allowed cultivators to reduce run times of the lighting due to the increase in ppfd, which is the number of photosynthetically active photons that fall on a specific spot on the plant each second. Outside of having higher efficiency, LEDs provide the benefit of higher efficacy compared with traditional horticultural lighting equipment. For example, modern horticultural LED fixtures have efficacies in the range of 2 times that of single-ended high-pressure sodium fixtures. So, not only will LEDs provide reduced electricity consumption and reduced heat load on the HVAC system, but they also allow for shorter daily light interval to be achieved, all of which creates a cascading benefit towards tremendous energy cost reduction. Furthermore, cooler running temperatures of LEDs could be the option for increasing your canopy space through stacking, and lights can be mounted much closer to the plant than traditional lighting equipment. Be sure to consult with a vendor well-versed in horticulture who can assist you with ppfd mapping of both existing and post-installed lighting upgrades so that you can select the best LED product for your facility, configuration, or cultivars. The reduced heat load may require some adjustments in the HVAC operation to ensure adequate growing temperatures are not exceeded during colder months. If this is not considered, you may create a need for supplemental heating, which becomes an unexpected cost and could negate some of the energy savings of your lighting upgrade. Understanding how and when lighting and HVAC equipment interact with each other to achieve favorable growing conditions is key to designing an efficient cultivation facility. Let's move to cover the HVAC and dehumidification equipment. These are the two most significant energy users of an indoor cultivation facility. This is the equipment that helps you manage the temperature and humidity within your cultivation space. Technically, they are two separate operations, and many cultivation facilities rely on entirely separate equipment. But from the perspective of energy savings, we will cover them together. First, costs and availability tend to drive what kind of HVAC equipment is used for indoor cultivation. In most cases, off-the-shelf equipment is selected, and although conditioning of the indoor air is exceeded, a majority of that equipment is not specifically designed or set up for the specialized needs of plants. They are meant for space conditioning the needs of humans, cold storage, indoor pools, spas, and so on. This standard HVAC equipment has the capability to dehumidify air, but not well enough to manage the output of plant transpiration. So, a facility needs to supplement with standalone dehumidification equipment within the cultivation space. At many cultivation facilities, HVAC and dehumidification equipment is added or altered as the need is determined or as the cultivation activity expands. This results in a collection of equipment operating independently from each other and sometimes competing to maintain set points specific to the needs of the system. Operationally, this is quite inefficient, but also energy inefficient. Not to mention, it introduces several unnecessary obstacles to maintenance practices and biosecurity protocols when several pieces of equipment are operating inside the growing space. A more efficient approach, both from an operations and maintenance standpoint as well as an energy reduction best practice, is a collective centralized system that has HVAC and dehumidification functions integrated. Often called a central plant or a chilled water system due to the method used for moving heat, this kind of system relies on a single piece of equipment to condition the air, then distributes that air to various areas of the cultivation facility through air handler equipment. Dehumidification can also be integrated within this type of system. As a more robust system, it provides greater precision, temperature, and humidity control across several growing rooms. Since its ports are integrated, the risk of competing equipment operation is eliminated, and there is also fewer parts to maintain. Systems intentionally designed for indoor cultivation also allows for all mechanical equipment to be outside of the spaces where plants reside, which provides the added benefit of biosecurity, risk reduction, and ease of maintenance. To recap, lighting, HVAC, and dehumidification are the three main energy users at your indoor cultivation facility. Therefore, they should be considered the primary areas of opportunity to increase energy efficiency and earn incentives. Here are the key takeaways for saving energy in indoor agriculture and cannabis cultivation facilities. Advanced LEDs can save both lighting and cooling costs. Designed for the interactive effect of lighting and HVAC. And last but not least, a central plant is the most efficient system for HVAC and dehumidification. For more information about potential incentives or to schedule a free energy audit with the AgEASY team, contact us today or visit our website at AgEASY.com.